Alright ladies, so as promised, here's another video to kind of help you through some of this stuff. Basically what I'm going to do here is show you another way to solve these type of problems down here that is similar but a little bit different than what we covered in class a couple days ago. In class I put these on the board. If you were absent, you may want to pause the video and copy these down because you're going to need them in your notes, and we're definitely going to need them when you get back from service projects. So anyway, what I wanted to show you is how you can, another way to do some of these problems, and in my opinion it's actually a little bit more efficient, and the positive is you actually don't need to use these up here. This is another method that just kind of goes back to our basic understanding of trig. So again, we're going to kind of read through the question here. Find cosine of theta if sine of theta equals 3 over 5, and the other restriction is theta is in quadrant 3. So I'm going to go ahead and draw our quadrants in here. Quadrant 1, 2, 3, and 4. And because they said quadrant 3, I'm going to go ahead and circle that. And remember, tangent is the only one positive in that quadrant. But we're actually looking for cosine, so chances are our answer is going to be negative. So instead of using these identities up here, we're actually going to just draw a triangle. Because after all, trigonometry is the study of triangles, and a right triangle at that. Now what you want to do is you want to take theta and label one of the angles as theta. And it actually doesn't matter which one. I'm going to go ahead and choose this one. So once we've got it labeled, remember sine, remember our SOHCAHTOA. Sine is the opposite over hypotenuse. So in this problem, if sine of 3 over 5, if sine of theta is 3 over 5, that means our opposite side is 3, our hypotenuse is 5. So in reference to this angle down here, our opposite side is 3. I'll use a different color for you. Our opposite side is 3, and then our hypotenuse is 5. Then by using Pythagorean theorem, or if you recognize the Pythagorean triple, 3 squared plus b squared equals 5 squared, solve that out, you'll figure out that b equals 4. So now that you have your triangle labeled and your angle, you can pretty much calculate cosine by using good old SOHCAHTOA here. So cosine, remember, is adjacent over hypotenuse. So if we're back to the angle that we chose, and again, you can choose this angle, and the label would be a little bit different, but it doesn't matter. So adjacent over hypotenuse, so adjacent is 4, hypotenuse is 5, therefore our answer would be 4 over 5, and because it's in the third quadrant, that means the cosine is going to be negative. So that would be your answer. So that's one way. That's basically another way to do this without actually using these up here. Don't get me wrong, we are going to use these when you get back from service projects, but for these problems, this is just another method if you're having trouble solving it with those. Then down here, if they ask for all 6, it actually is a lot more efficient. I think in the last bit of your homework, you have to look at all these problems. So, or solve all 6 of them. So instead of going back up here and solving fractions and adding and subtracting fractions like we did in class, again, you can draw yourself a triangle. Again, pick an angle. Doesn't really matter which one. Let's choose this one this time. Really doesn't matter. And then tangent, as we mentioned up here, is opposite over adjacent. So the 5 is the opposite, 12 is the adjacent. So if the opposite is 5, adjacent is 12. Again, use Pythagorean theorem, so 5 squared plus 12 squared equals whatever that side is. We'll call that c squared. You solve that out, you'll figure out that that's 13. You've got your entire triangle labeled. Once you have your triangle labeled, you can just go through and answer all these questions very easily. Sine, because it's opposite over hypotenuse, well, opposite over hypotenuse, 5 over 13. Therefore, this is going to be 13 over 5. Cosine, adjacent over hypotenuse, so 12 over 13, 13 over 12. Then they already told us tangent, it should be a 12, sorry. And you just switch that to 12 over 5. Now notice tangent's negative, so that doesn't affect your triangle. You always just want to use positive numbers for your triangle. Then you just say, okay, so it's quadrant 2. So if it's quadrant 2, we're talking about this one. So everything's sine is the only positive one there. So cosine tangents should remain negative, and then cosine is also negative. Sine should be your only positive. And that is the other way to do these. So what you may want to do is practice this with your homework, or you could even rewind this and pause it before I actually do the problem and then see if you can get it right. Hopefully this is helpful, and if you have any questions, we can go over this next class. All right, talk to you later.